So in the last video I gave you two programs to practice on. In this video let's solve those and continue on to studying about string manipulation. So for the first one I asked you to print blank spaces about 10-20 times in an easy way. So if you guys thought you would just print this and do that 10 times, that would be very lengthy. So instead let's think, why does printing an empty space go to the next line? Now the reason is the print function has three things. There's the value that you put in, then there's the separator, and which we will talk about later, or I think you already know about it, and then there's the end. So the end, let's try it. So let's say 1 2 3, okay, and then I say end is equal to ABCD, right? So now what happens is we type a string and we end with the ABCD. Now by default the end by default is this thing, /n, and what that does, it basically goes to the next line. Although it doesn't look clear here, but if we had done this in, let's do it here. Okay, so this is the first print function. Let's do it in the file mode. So that's 1 2 3 ABCD, and this one, let's see. So you can clearly see what just happened here is that it printed the 1 2 3 ABCD, which obviously had to print, but because it didn't go to the new line character, it didn't go to the next line, the next print statement happened just here, the 1 2 3. So what you can do is basically you can say print the new line character. So you could print the new line character itself. So this one, you could print the new line character and you print it 10 times, right? So let's see what happens. And it left, I think it left 11 spaces. Oh yes, the reason is because our end is by default that. So let's change that to nothing. So this time it will leave exactly 10 spaces. Yes, so that's how you do that program. Now the other program I believe was extremely easy. All you had to do is use the in operator to check if the username was in the password or not. Alright, so let's continue. Now there are some other operators which we can use with strings, and that is the comparison operators, or the bigger than, equal to, the double equal to, not equal to, and etc. Actually not the single equal to, just the double equal to. Single equal to is kind of different, it's only for assignment. So let's say I have a string and I check if it is equal to some other string. So it isn't equal to, so it says false, which I think is very self-explanatory. If we did this, obviously it will be true because this and this are basically equivalent. Now we could have done something. Let's say there's the other not equal to operator. Let's do that. Let's check if small a is equal to capital A. No, it is not, and that's why the not equal to returns true, because a is not equal to capital A. So what other operators are there? There's the bigger than and the smaller than. Bigger than, equal to, smaller than, equal to. So let's see what happens there. Let's say a, is it bigger than capital A? Most of you would say no, obviously capital A is bigger. Let's see what happens. It says true. So it isn't the way you think it is. What actually happens is Python takes the ordinal value of a. Let's see, small a, what's the ordinal value? 97. Ordinal value of capital A is, let's see, 65. So 97 is bigger than 65, so therefore small a is bigger than capital A. So when we are dealing with bigger than, smaller than, or even the equal to, double equal to, not equal to, all these different comparison operators, we are actually dealing with integers here. 97, 65. So we are actually dealing with integers. Here we are checking if 97 is equal to 97. Actually we are checking if 97 is not equal to 65. So that is what's happening. We are using the Unicode, the ordinal values of the characters. Now what would happen if we do, let's say, ABC? Is it bigger than ABC? What would you guys think about it? Is it bigger or not bigger? It says false. It seems that ABC is bigger. Now you can think of it as combining the different ordinal values, but actually that would give you a lot of errors and a lot of mistakes. The easy way to understand is with such multi-character strings is that you could think of it as in the dictionary. How would it look in your dictionary? If you had your dictionary, in this hypothetical dictionary, you could say the so the easy way to understand why ABC bigger than ABC returns true. Why is this considered bigger, right? Let's see. So let's say you have two names, Andy. Let's say if it's bigger than Alex or not. It says true. Now the easy way to understand in such a case, now it isn't combining the ordinal values and finding which is the largest in such a case. When it comes to multi-character strings, it is slightly different. So but it's kind of complicated. So the easy way to understand is that if you put these names in a dictionary, which would come first? Let's see. So there's A in both, and then there's L and N. So let's see, L, M, N, O. So N comes last. First L comes, and then M, N, O. So N is there. So N comes next. So what comes next, or what is in the last in the dictionary, is bigger. So what comes first in the dictionary is smaller. Basically, that's an easy way to understand. So let's try something else. So let's say Aaron is smaller than Abron. Now let's think about it. We know that what comes in the last is considered bigger, right? So obviously this means that Aaron, this is coming the first before Abron in the dictionary, so this must be smaller. So this might be true. Let's check that, and it says true. So that's how it works. You can put another name. You could put Bunty bigger than Rahul. So let's check what that does. It says false. Now let's see why. Now obviously if we look at the dictionary, Bunty comes first, so it's smaller, but Rahul comes in the last, somewhere in the near end of the dictionary, so that is larger. So that's why this is false. If we do this instead, it would make more sense. It would say true. Now what about something like this? Let's say you have this and you have this. So there's something with the small and big characters. Let's see what that does. So interestingly, that has changed a little bit. Now we knew before that Bunty is smaller than Rahul in the dictionary, but this time the small Bunty, the small character Bunty, is not smaller than Rahul. In fact, small Bunty, let's actually write that down and change the angle bracket. In fact, this small Bunty is considered bigger than Rahul. Now in this particular hypothetical dictionary, we consider that these small characters, the small characters come in the last, kind of in the last, so after the big characters, so they are going to be even more larger. So this would mean that if we took an Andy and we checked if it is bigger than Andy, one is in small, one is in caps, that would indeed be true, because Andy comes afterwards of the capital Andy. This comes afterwards in the dictionary, hypothetical dictionary. So that's how it works. Alright, so before we end, I would like to give you another program. So in this program what you would have to do is, I'm going to show you, we're going to make another pattern. So the pattern will look like this: A B, A B C, A B C D, B C D E, A B C D E F, and this would go on depending on what the user wants. You could go on till Z. Let's say you want to do that. Let's say you want to keep going on till Z, A B C D E F G, and goes on to Z. So this would be the pattern you would be creating. The twist is, I think you already know how to do it, but the twist is you cannot use nested loops. You can use loops but not nested ones. So try it out.